everyone. My name is Tyler Lynch, and I'm going to be talking about the detection of antibiotic residues in milk across sheep, goats, and cows. My three main topic questions are going to be why are these antibiotics being used in the dairy programs? What is used to detect these antibiotic residues in milk? And why is the detection of these antibiotic residues important? So why are these antibiotics used in the dairy programs? Antibiotics are commonly used to prevent infections and diseases such as mastitis. These antibiotics can be used as growth promotions and as proper herd health management for these antibiotics being used so they do not transfer these infections or diseases across the herd. So how are these these residues being detected in milk? These are the four most common tests that I found across my research, where the Beta Star combo test is the most popular test to where it is easy to use for the dairies, the farmers, the truck drivers, or the milk receivers, and even the testing labs, and they can get results fairly quick within 5 minutes. The SNAP test is the second most common test, but it takes a little longer to where you have to heat the heating pad up at a constant temperature for at least 15 minutes. And then you have to select a certain test for a certain antibiotic residue that you're looking for. And then once you mix in the solution, you have to incubate the milk solution for at least 5 minutes. And then after that, once you put this the solution in, you have to activate the test at a certain time or the results can be skewed. The good thing is it's easy to read, to where the more residues that are in the solution, the lighter the color will be. The twin sensor test is similar to the Beta Star combo test, to where it only takes about 4 to 5 minutes to receive the results, but you can only test for 2 antibiotic residues. The near infrared tests and the research that I found, they were using near infrared machines to detect multiple antibiotic residues just using one test. For the Beta Star, the SNAP, and the twin sensor test, they use strips like these that can be read visually or with an electronic machine, to where they shows a negative, a weak, or a strong positive. And then depending on the test, you'll have different strips for the beta-lactam or the tetracycline residues. And all the research that they showed, that they said that their results showed the residue limits were under the limits for consumption. But they never said what the limits actually were, and then I had to find these limits from the FDA, and these are the 7 most common antibiotic residues that were used in each study that I found, to where the levels were represented as in parts per million. So why is the detection of these antibiotic residues important? Consumer preference is probably the most important, because consumers are not going to buy milk products that are going to have these antibiotic residues in them, which can drive milk consumption down dramatically. Consumer health, where scientists are really concerned that consumption of these milk products that contain these antibiotic residues that could lead to allergic reactions or even resistance of these antibiotics. Conclusions: there's a lot of research going on to where the Beta Star and the SNAP and the twin sensor test, they were successful in detecting antibiotic residues across species in cows, sheep, and goats. Other tests like the near-infrared test, where they can test multiple antibiotic residues with just one test. They're also using microbiological tests to test for these antibiotic residues. And there's just a lot of research going on, and scientists are really concerned with these residues. Producers and the farmers are responsible for these antibiotic residues in milk, to where they need to administrate these antibiotics properly at the proper times and abide by the withdrawal periods before collecting milk from these animals, so that these residues do not end up in the dairy products. These are my references. If there's any questions, please ask. Thank you.